Algebra 2, Radical Functions and Equations Study Guide for Unit 4A, Concept 17 problems. So we're going to look at problems 1 through 13 in this section of the video. So the first thing we're going to do is find the nth root of each. And just remember this, that when we say nth root, this is the form that we use. So when you have n equals 3 and a equals negative 125, that's asking for the third root. So we put that right in the crook of our radical of negative 125. So it is going to be a negative number. You can put that on your calculator. You could also break it down. So we're just thinking of positive 125. And what we're looking for is a number that repeats itself 3 times. And because our number underneath is negative, then the root will be negative. Number 2, we're looking for the fourth root, because n is 4, of 81. You can put that on your calculator, or we can just break it down using a factor tree. So I just think of 2 factors of 81, which is 9 and 9, and then I'm going to break that down all the way down to the prime factors. I'm looking for a number that shows up 4 times, because that means that it's multiplying by itself 4 times. So 3 is fourth root of 81. And then the second, or the square root, of 144. And that equals 12. We're continuing to just simplify nth roots. So the third root of 27, you can break it down using a factor tree. So think of factors of 27. I often think of 9 and 3. And then I'm going to continue breaking down any numbers that aren't prime, multiply by 1 in itself. And so I break down 9 into 3. I look at the ends of my branches and notice that 3 is there 3 times. So that means 3 to the third power is 27. Now on this one, so the third root of 32, we can think of that as 8 times 4. We can break down 8 further into 2 and 4, and then break down our 4s, 2 times 2, and another 2 times 2. So I'm looking at the ends of my branches for a number that repeats itself 3 times. So I have a group of 2's there, so that means I have a third root. And then I look at what I have left. I have 2 and a 2. So I'm going to put them back together because that's not a third root underneath. So the third root of 32 simplified is 2 times the third root of 4. And then finally the square root of 8. So we can think of that as the square root of 4 times the square root of 2. And then we can take the square root of 4, which is 2, and then times the square root of 2. On 7 and 8, we're continuing to look at nth roots. So we've got the third root of 8x to the 7th, y to the 5th, z to the 12th. So we'll just take it one piece at a time. We want the third root of 8. So a number that will multiply by itself 3 times to give you 8. You can put it on your calculator. We can also break it down into its factors, and we'll see that 2 is a third root of 8. So 2 gets to come out of the third root. Then we're going to look at x to the 7th. So the question changes. How many groups of 3 x's are there in x to the 7th? Well, there's 2 groups with 1 x left. And then with our y to the 5th, how many groups of 3 y's are there in y to the third power? Well, there's 1 with 2 left over. And then lastly, how many groups of 3 z's are there in z to the 12th? Well, there's 4 even. And I'm just going to kind of rewrite. With the third root of our single x and our y squared left. All right, number 8, we're going to approach it the same way. So the fifth root of 32, you can put that on your calculator. We can also break it down. So I'm just going to start. I know that 32 is even, so I can divide it by 2. I'm looking for a number that shows up 5 times, and I see the 2. So that means the fifth root of 32 is 2. Now, we look at x, that's to the first power. So how many groups of 5 x's are there in x to the first? Well, none, so that has to stay. How many groups of 5 y's are there in y to the sixth? Well, there's one group of 5 with one left. And then how many groups of 5 z's are there in z to the fifth? Well, just one group. Now we're going to use properties of radicals and rationals to simplify these expressions. When you have a fraction where you have the same roots in the numerator and the denominator, you can combine them. So that can be the fourth root of 208 divided by 13. And then if you divide that out, then that is 16, which is convenient because 16 does have a fourth root. Now I'm going to show you, I'm going to break it down to its factors, but there you can see it. 2 multiplied by itself 4 times is the fourth root of 16. Now number 10, we're using properties of exponents. So the first thing we want to do is add these exponents since the powers of 3 are multiplying. So negative 2/3 plus 1/3, is negative 1/3. Now that's still raised to the negative 1 power. When we raise a power to a power, we multiply. So negative 1/3 times negative 1 is positive 1/3. So simplified, we have 3 to the 1/3 power. And then lastly, we need to subtract 12 square roots of 5 minus 2 square roots of 125. Well, we can't do that because our square roots are not the same. But we can simplify the square root of 125 just to see what will happen. So that'll break down in the square root of 25 times 5, which is good because we can take the square root of 25. So bring your first term down, and then we'll take the square root of 25, which is 5. It's going to multiply by the 2 that's already out there. So when we simplify that, we've got 12 square roots of 5 minus 10 square roots of 5. Now we can do that problem because that'll be 2 square roots of 5. We'll finish up the concept 17 problems by more properties, using properties of roots and exponents. So if you have 2 roots that are the same multiplying together, you can just multiply their values. So 12 times 18 is 216. And then you take the cube root of 216, you can do that on your calculator, and you will get 6. And then on 13, notice that we have 72 to the 1/5 power divided by 9 to the 1/5 power. So since the power is the same, we can go ahead and divide 72 divided by 9, raised to the 1/5 power, then raised to the 3rd power. So 72 divided by 9 is 8. 8 to the 1/5 raised to the 3rd power will be 8 to the 3/5 power.